ever. Log4Shell, discovered at the end of 2021. Basically, it let attackers to run code on your servers just by getting something logged. Yeah, logged. It was that bad. Let me break it down. First, quick recap. Log4j is a super common Java logging library. You've probably used it, maybe through frameworks like Spring, Kafka, or Elasticsearch. Even if you didn't pull it in directly, it's been the default logger in tons of projects for years. So yeah, this thing is everywhere. When the Log4Shell bug came out, it went viral overnight. People were hacking Minecraft servers just by typing stuff to the chat. Botnets, crypto miners, even some government systems got hit. Basically, anything exposed to the internet that used Log4j and logged user input was fair game. So, if someone sends a string, like this, and it gets logged, that's enough to trigger the vulnerability. That's what made this whole thing so wild. No file upload, no out, just a log line. So here's what was really going on. Log4j supports placeholders in logs, like date or env. Handy stuff. But it also supported this syntax, which can do lookups, using Java's JNDI system. If you haven't used it, JNDI is kind of like DNS, or a phone book. It lets Java app to look up resources by name, stuff like databases, directories, etc. The issue is, it also lets fetch Java objects from remote servers, like serialized classes. That's usually fine inside a trusted network, but when user input gets mixed in, not so great. Attackers mostly used LDAP in their payloads, but RMI and DNS were also used in some cases for data leaks or detection. And yeah, some older Java versions would even automatically load and execute whatever came back from that server. So, if you logged untrusted input, like a user agent, a form field, anything, and it included JNDI placeholder, boom! Your server could reach out to the attacker's LDAP server and run whatever Java class they sent. And that's how a simple log message turned into a global incident. Now I'll show you with a quick local demo how the exploit actually worked. It's that simple and kind of scary. Before we start, here's the basic idea. We send a message with JNDI lookup to the vulnerable app. That app logs our input using Log4j. Log4j resolves JNDI placeholder and makes a network call to the attacker-controlled LDAP server. LDAP replies, "Hey, go grab this class from my HTTP server." The app downloads the class and runs it, just like that. Yep, that's full remote code execution, all from logging a bad string. Now let me show you what I've set up in IntelliJ. It's just three components. A vulnerable app. It's a Spring Boot app that listens on feedback and it prints the message field using Log4j in version 2.14.1, which is one of the vulnerable versions. Additionally, it has enabled JNDI LDAP object trust URL codebase, just like it was done by default in older Java versions. Thanks to this property, we're allowed to load remote classes via LDAP. The next component is malicious LDAP server. It's built on Marshall-Sec repository. It's a fake LDAP server that provides reference to our exploit server. The next component is exploit server, which just serves our exploit class. And our exploit class just prints a message and shuts down the application. And everything is wired together using Docker Compose. Alright, let's bring everything up with Docker Compose. Now we have two terminals side by side. On the top is Spring Boot app. On the bottom, I will be sent crafted request with JNDI lookup. You'll see exploit reach our application and JVM shuts down because our exploit called system exit. And that's full remote code execution, all from just getting a string logged. So, which versions of Log4j were actually vulnerable? Any app using Log4j in version 2.0 beta 9 through 2.14.1 was at risk. Apache released a quick patch, 2.15.0, but it didn't cover all the edge cases. So they released 2.16.0, which disables JNDI completely. Then they introduced 2.17.0, which covers another denial of service issue. Basically, if you're on anything older than 2.17.1, you should update. Here's what this whole mess taught us. Don't assume logging is harmless. If you're logging untrusted input, treat it like any other dangerous surface. Keep your dependencies up to date. Seriously, even if it's just logging. Know what features your libraries enable by default. JNDI lookup? Probably not something most of us ever needed. And finally, think about egress. If your app has no reason to reach out